So once again, we are asked to graph three functions on the same set of axes. I've gone ahead, in this case, it's f of x equals x squared, g of x equals x plus 2, and or x plus 2 squared, and h of x equals x minus 2 squared. I went ahead and did x squared, our parent function, because we should have a general idea. Notice that the scale on this graph is 3 units for each grid square. The reason being is because you'll see in a little bit it gets a little out there as far as the points are concerned with a couple of our transformations. So now we're going to look at g of x equals x plus 2 squared. Our inputs are -3, -2, -1, 0, 1, 2, and 3. So if we start with -3, -3 plus 2 is -1 squared is 1. So our point is going to be -3, 1. At x equals -2, -2 plus 2 is 0, squared is 0. So our point is going to be -2, 0. At -1, -1 plus 2 is 1. 1 squared is 1. So our point is going to be -1, 1. At 0, 0 plus 2 is 2. 2 squared is 4. So our point is going to be 0, 4. That's going to be our y-intercept. And then we should notice symmetry here. At 1, it's going to be 3. 1 plus 2 is 3. 3 squared is 9. So the point is going to be 1, 9. 4, or at 2, sorry. 2 plus 2 is 4. 4 squared is 16. So our point is going to be 2, 16. And then 3 plus 2 is 5. 5 squared is 25. So our point is going to be 3, 25. We'll go ahead and plot those in a different color so we can see exactly what's happening. So let's plot those points. -3, 1 is going to be right about here. -2, 0 is going to be right about here. -1, sorry, -1, 1. So -1 is going to be about here. 1 is going to be right about here. 0, 4. So each one of these is 3, 4. 1, 9. So 1's about here, and then 3, 6, 9. 2, 16. So 2 is going to be right about here, and then 3, 6, 9, 12, 15, 16 is going to be right about here. And then 3, 25. So 3, and then 3, 6, 9, 12, 15, 18, 21, 24, and then 25 will be right about here. And we could go ahead and, like I said, we could use points of symmetry to graph these points over on the left-hand side, but we get the general shape. And the main thing we want to notice here is look at where the individual points are. Mainly the vertex. We started out at 0, 0. Where's our vertex? Well, it's at -2, 0. So each one of our points, if we look, they are shifted to the left. And again, that's mainly revealed with the vertex. Because our x values, we weren't looking at shifted x values. But if we want to look at that, well, what's the value at -5? Well, -5 is -5 plus 2 is -3 squared is 9. So at -5, it's at 9. At -4, it would be at 4. We're shifting all of these points to the left 2. Now, what about x minus minus 2 squared with h of x. Let's look at that. At -3, -3 minus 2 is -5 squared is 25. So our point is going to be -3, 25. At -2, -2 minus 2 is 4, or -4 squared is 16. So our point is going to be -2, 16. At -1, it's -1 minus 2 is -3 squared is 9. So our point is going to be -1, 9. At 0, 0 minus 2 is -2 squared is 4. So it's going to be 0, 4. At 1, we have 1 minus 2 is -1. -1 squared is 1. So we have 1, 1 as a point. At 2, we have 2 minus 2 is 0. 0 squared is 0. So we have 2, 0. And last but not least, 3 minus 2 is 1. 1 squared is 1. So we have a point at 3, 1. And we should notice here that that means the vertex is at 2, 0. So let's go to 2, 0. Remember, each tick mark is 3. At 1, we're at 1. Should be right about here. At 3, we're at 1, which again is right about here. 0, we're at 4, so 3, 4. -1, we're at 9. -2, we're at 16, so 3, 6, 9, 12, 15, 16. And at -3, we're at 25, so -3, and then 3, 6, 9, 12, 15, 18, 21, 24, 25. And again, connect those dots. And we could use symmetry for our other points. But the main thing we want to focus on is look at these vertexes right here to here. This one's at 0. This one's at -2. And this one is at 2, x equals. So what does that show us? Describe what effect adding a constant to x has on the basic parabola. So with f of x equals x squared, g of x equals x minus a squared, shifts f of x a units to the right, and h of x equals, I did this backwards from what we were given, but it means the same thing. H of x equals x plus a squared, shifts a units to the left. So we don't have to plot points if it's in the form x minus or x plus a squared. We can just shift the points from f of x equals x squared that many units to the left if a is being subtracted, or excuse me, that many units to the right if a is being subtracted, and that many units to the left if a is being added. It seems a little bit counterintuitive because when we're subtracting, that's a shift in the positive direction. When we're adding, that's a shift in the negative direction.